Alright, good evening, gang. Today we're going to be able to talk about using graphs to represent relationships between two quantities. If anything, when you walk out of this classroom by the end of this year, you will for sure know how to graph. We've been focusing a lot on it this last week. Now let's go ahead and go into interpreting our graphs. Alright, go ahead and title this page in your notes. Representations of graphs. Your essential questions is how do you use graph to represent relationships between two quantities? There are three major things that we use to describe graphs. One is increasing. Two is when it's consistent, no change. And three is when it's decreasing. The fourth thing we like to add into when we're talking about graphs is how quick or how slow. So quick or slow. And it's always important that you're talking about the units. And then 5, always talk about units. Always talk about units. units. Okay. So if I went too quickly, please pause your video. Here's your 5 things that you must include or look for when you're representing graphs. Our first example that we're going to talk about is the temperatures between two different cities, and we're going to describe the temperature in each city. Remember, we're using 1, we're going to talk about when it's increasing. 2, we're going to talk about when it's consistent. Sorry, running out of room, so I'm abbreviating. 3, we're going to talk about when it's decreasing. 4, we're going to talk about the speed of all 3 of those. And 5, we're always going to be including units. All right, so when we're looking at Maine, we see that we're increasing until about halfway through time, so through the day, and then we start decreasing. So there's a point at which it changes direction. We're going to say for Maine, about halfway from the beginning of the day to halfway through the day, time increases quickly and inconsistently. That would probably be better because it's not a line, it's kind of a curvy line. So as time increases, so does temperature. I'm going to abbreviate TEMP, sorry, temperature, temp, until halfway through day, the day where it decreases, it starts to decrease. Increase, both of which are not consistent. Both of which are not consistent, meaning making a line. Okay, let's go ahead and talk about Oregon. Oregon's temperature first decreases, stays consistent, and then slightly increases. This is where we're talking about that speed, a slight increase in temperature. So, Oregon. As time goes on, the temp decreases to about 1/3 of the day, then stays consistent. I'm going to have to abbreviate that one for about 1/3 of the day. Lastly, for 1/3 of the day, there's a slight increase. Please write down what I said. Write down what I said. Okay. There we go. Now let's go ahead and make comparisons between the graphs. So our Maine in comparison to Oregon, they both have increasing, they both have decreasing. Okay. They both do not know consistency. And then the last thing I would say, a major thing, is that Oregon starts off decreasing and Maine starts off increasing. They're like opposites. All right, the next example. You have to be able to sketch graphs. A stopped subway train gains speed at a consistent rate until it reaches a maximum speed. It travels at this speed for a while, then slows down at a consistent unit rate, coming to a stop at the next station. So our first thing we got to look for is our units. So our first unit is speed, and our second unit must be time because it's talking about how it then stops at the next station. So, sorry, I'm going to make this an A, I'm going to make this a B. Let's go ahead and make our graph. Speed will go in the Y because rule of thumb, time will go on whether speed does or not. So time must be independent. Okay, let's go ahead. Stop gains speed at a consistent rate, so it's a line. Gains speed at a consistent rate until it reaches a maximum speed. Then it travels the speed for a while, so I'm going to try and make a straight line. Travels the speed for a while. And sorry, my graph is slightly curved, so I'm making mine curved a little bit. Then slows down until it comes to a stop. There we go. That's all I've got to be able to do. As television size increases for the price, the rate increases. So this one's talking about as television size depends on, price depends on size. So as television size increases, the price increases at an increasing rate. So this one will be a curvy one because this is an increasing rate. There we go. If it doesn't say consistent, then it's not a straight line. Increasing at an increasing rate means curvy. All right, go ahead and try these two on your own. Check back in when you're ready to go over your answers. Thanks for pausing your video. Okay, describe the change in the bacteria population over time. So this one would be at an increasing rate over time. Bacteria population increases at an increasing rate over time because it's curvy. Okay, sketch a graph that represents the situation. After takeoff, the altitude of an airplane increases at a consistent rate, then remains. So this is going to be time because it's talking about after takeoff. This is going to be talking about altitude. After takeoff, the altitude, so their altitude won't be 0 because they already took off, increases at a consistent rate, then remains consistent for a time, then decreases until the airplane lands. The important part for this one is that you're starting off already above the 0, mark. All right, go ahead and answer your essential question, go through it and take that checkpoint, and we'll see you guys tomorrow.